Okay, earlier I talked about infinite limits. Okay, talked about infinite limits. In those problems, x was always approaching a specific or a finite value. All right. The difference is with limits at infinity is actually the limit as x approaches infinity. So in other words, as my x values get really, really big, or my x values get really, really small negative, what is happening to the y value? All right, that's kind of what goes through my head when I see these limits at infinity or at negative infinity. I think, what is happening to the function, or what is the y value of the function approaching as x gets huge or negative huge? All right, in a sense. I'll go back to kind of the most common function that we'll use for some of these, and everything's kind of based off of that. And this one is very logical to you as you understand the functions. What is the limit of 1 over x as x approaches positive infinity? So in other words, as x gets huge positively.
0.
Why?
Because then the graph comes down to the...
Okay, so Caleb referred to the graph, and he said, well, I know what this graph looks like, and the graph does this over here, so as x goes to positive infinity, I know my graph's getting really, really, really close to 0. So that was your logic behind your answer. Your answer's right, it's 0. Okay? Nick?
1 from 0 and put infinity under a 1 is pretty much 0.
Yeah, absolutely. 1 divided by a quadrillion is 0.0000000, I don't know how many zeros, 1. That's practically 0, right? And as that value keeps getting larger, 1 divided by a huge number is going to get closer and closer and closer to 0. It'll never actually get there, but the limit of it will be 0 because I'm getting so close to 0 itself. So whether you think of it numerically, like Nick did, he thought, well, I know 1 divided by a huge number is practically 0. Or you think of it graphically, like Caleb did, draws the graph and see, okay, well, what happens as I go way to the right on my picture? You know, what is the y value doing as I go way to the right? Or if I said negative infinity, as it goes way to the left. You can do it either way. So graphically, numerically, whatever makes the most sense. Okay? You're also going to have ones where I'll ask you to do it algebraically, and I'll show you how to do those in a second. Okay? If C is a constant, just kind of give you a little rule here. If C is a constant and N is a positive rational number, then the limit of C over x to the nth as x goes to infinity would always equal what? Let's see if you can figure this out just with my variables here. C can be any constant in the world. If I have some number divided by x to the nth power, where n is not negative, okay? N is some positive rational value. What will this limit always equal?
0.
Nick says 0.
Yeah, I'd say 0.
What's happening to the bottom of this fraction as x gets larger? Getting raised to a power. So therefore, what's happening to the bottom of the fraction? It's growing larger and larger and larger, right? There's no way that it's not. What's happening at the top? Staying the same. It's a constant. So even if this constant is 1,000,000, this value is growing so much past 1,000,000, you have a small number divided by a number that's growing forever, so the limit will always be 0. This is very similar to the first function I gave you, the 1 over x, except I'm saying it works for any constant. over some power. Okay? If the variables are confusing you, I could write up a whole bunch of these. Okay? What's the limit of 5 over x to the third as x goes to infinity? 0. Because what's happening to the bottom? It's getting huge. 5 divided by a huge number practically equals 0, right? Questions on that? Okay? Silence is good or not?
Yeah.
Okay? All right. Let's see. The limit as x approaches infinity of x squared. Infinity. As x gets huge, what's the y value doing? Getting bigger, it's squared. Okay. What's the limit of x cubed as x approaches negative infinity? Would it be negative?
Yep.
Why?
Because negative cubed.
A negative cubed is still
Negative.
negative. What if I would have put a negative infinity up here?
Positive wouldn't have mattered.
Still would have been positive, because a negative number squared still approaches positive infinity. But this one happens to be negative infinity. Right? Well, if I put a negative, that'd be just like 1 over x cubed, so that'd be 0. But, yeah, I'm going to change things up on here.
Infinity. 2x is not. Will it still be infinity?
So, Dakota's saying infinity. Alright?
I see 0.
Anybody say anything different?
Let's just run.
The 2x is like,
It's infinity minus
the 2x
infinity.
means nothing.
Jack, go ahead.
Well, like the 2x is like nothing because you have the infinity 0, it's going to get cubed.
Yeah.
So you're saying this is outweighing this, so this is like
Yeah, 2x doesn't mean
minuscule compared to this. Anybody else? Nick?
If you plug infinity, it's both infinity.
Okay.
Yeah.
Okay. I wanted someone to go there. Okay? So, I got two different arguments here, and that's what I wanted to point out. So, Dakota said infinity, Jack said infinity because this one far outweighs this one. Here's what Nick said. Okay? Well, if I separate them, the limit of this one is infinity, the limit of this one is infinity, and infinity minus infinity is 0. Okay? Now, which, going through logically, I can see how that makes a little bit of sense. Okay? But, Jack's answer, or explanation, is the correct one in this instance. Let me show you algebraically why. Okay? Yeah, no, I'm glad you brought it up, because I was going to bring it up. Okay, I'm not saying that your answer's going to be wrong. So, what I'm going to do is I'm going to factor out an x cubed from each term. So that would leave me with x cubed times 3 minus 2 over x squared. I'm dividing each term by x cubed. When I divide 3x cubed by x cubed, I just get 3, right? When I divide 2x by x cubed, I get 2 over x squared. Everybody good with that? Okay, I'm just showing you algebraically why Jack's answer, or those guys' answer, that's the right one The logic behind it was perfect, but I'm going to show you how that worked. Okay? What's the limit as x approaches infinity of x cubed?
Infinity.
Infinity. What's the limit as x approaches infinity of 3?
3.
What's the limit as x approaches infinity of 2 over x squared?
Like super
So
small.
essentially that's 3 minus 0, right?
Yeah.
Okay, 3 minus 0 is 3, right?
Yep.
So, infinity times 3 is still infinity. Right?
Yep.
So, to quickly summarize that, I like Jack's thought that he said, all the lower powers mean diddly squat. Okay? That's as mathematical as I can be. They are so small compared to the highest power term. All you need to, if you have a polynomial means like 4x to the 5th minus 2x squared plus 7x minus 5, a polynomial, not a fraction, just a polynomial. All you need to do is look at the first term, or the highest power term, find the limit of that term, and you will be able to get your answer. Okay?
What if we just factored out x?
What was I had x cubed.
3x minus cubed minus 2x. Would be 3x squared. Would be x 3x squared is this.
Which would still be infinity times infinity.
Right.
So, yep. The limit as x approaches, we'll go negative infinity of 7x to the 4th minus 3x plus 8. What would the limit of that function be as x approaches negative infinity?
Negative. 0. What?
Could be negative infinity.
Well, you're in some negative infinities, positive infinity, positive, because it's raised to the 4th power. Changing your mind?
Yeah.
Okay, good. Alright? Think about you plugging in a very large negative number, negative 1 million. If you plug in negative 1 million, this has become a huge positive number because a negative raised to the 4th power is positive. These really don't mean anything back here. They're so small compared to this one. So this is what determines it. Plus, anything to the 4th, here's another way to think about it. Wouldn't this graph look something potentially like this?
Sure.
Well, squareds, 4th, 6th powers, 8th powers, all even powers do either do this or they do this, right? Okay, talking about end behavior, what the graphs are doing at the far ends. Okay, so what would this graph do as I go this way forever? It's another way to think about it. As the graph goes this way forever, it's increasing, so it makes sense that it would be positive infinity. But I don't need the graph to do that, I can just think about it. Okay? Alright? Now, one other type of problem would be with fractions.
8. Look sideways, just draw an 8.
Turn your, like, since you draw an infinity, you turn the paper and just draw.
Okay, thoughts here?
Ooh. 1. Would you have to factor it first?
Infinity over.
Well, let's factor it
It would be
first.
infinity over infinity,
One.
so that's logically saying 1. Okay? Makes some sense. Okay?
Well, the top would probably be smaller than the bottom. Well, not much smaller,
But these have little to do with it, right?
but yeah.
These are identical. but they do have a common, it's a ratio. 2/5. Yep, if you enter this function into your calculator and see what happens as your x values get huge, you're gonna approach 0.4 or 2/5. Okay? Now, here's how you do that. Here's how you see that. I'm gonna look at the highest power I see. X squared, right? I'm gonna divide every term by x squared. If I divide this by x squared, I get 2. If I divide this by x squared, I get 6 over x, right? If I divide 1 by x squared, I get 1 over x squared. Divide 5x squared by x squared, and I get 5. Divide 6 by x squared, and I get 6 over x squared. Okay? What's the limit as x approaches infinity of 2? What's the limit of 6 over x as x approaches infinity?
Really small. 0.
0. What's the limit of 1 over x squared as x approaches infinity?
0.
Limit of 5?
5.
Limit of 6 over x squared?
0.
Answer 2/5. That's the algebraic way to do that. Okay? Yes. Makes a whole bunch.